Welcome back to the MCG. Here we're going to look at arithmetic series. Okay, arithmetic series. And you remember the arithmetic series is, I'll go with this same one again, when you're adding together all the terms in an arithmetic sequence. Okay, so something like this. This is an arithmetic sequence because it's going up by 2 every time. But in this case it's a series, and so we're adding together all the terms. Now again, I'll prove this in class, but for now, if you've got a series with n terms in it, then if you add them all up together, then what you'll get is this: n over 2 times 2a. It's a little hard to remember this, and I'll show you something else, times d. Okay, so that's the formula for adding up any arithmetic series, okay, where d is the difference, n is the number of terms, a is your first term, okay. So it'll be that. Also, it's equal to something that's much simpler, but sometimes, or most of the time, is not very helpful. N over 2a plus L, where L is the last term, which is t. N, okay, that's your last term. So there is your two formulae. Getting better at this. Good. There's your two formula to be able to figure out the sum of a sequence. Where this came from is from Gauss. Gauss was an awesome German mathematician, and I'll just quickly show you where this comes from. I'll show it in class, but he was asked by his primary school teacher what the sum of the numbers from 1 to 100 were, and what he did, so let's just call this Sn, okay, it makes it a bit more easy. What's the sum of all these numbers? And what he did, which is really clever, and it's how this is actually defined, how these come about, is that he rewrote them in the opposite order. So let's write them in the opposite order. So 100 plus 99 plus 98 plus 3 plus 2 plus 1. Because what he noticed is that if you do that, then all of these sort of match up together. That one and that one. Can you see what the pattern is when you match these up? And hopefully you can see that if you add all of these things up, they all add to the same thing. And that was a really good little thing here. So let's add these two lines together, okay? So let's just start from here. What's 1 plus 100? It's 101. What's 2 plus 99? It's 101. What's 3 plus 98? It's 101. I'm not going to bore you. Plus plus 101, plus 101, plus 101. And what's Sn plus Sn? Well, that's 2 lots of Sn, so we'll just write 2 lots of Sn. Okay, we're just adding them together. And so, what is this equal to? I'm going to run out of space again. How many lots of 101 do we have here? Well, we've got 100. There's 100 numbers here. N is equal to 100 in this case. We've got 100 numbers. So really, that's 100 times 101. And so therefore, the sum, Sn, is equal to 100 times 101 divided by 2. And that's how Gauss actually figured this out in primary school, and this was the beginnings of the mathematics for this particular, I'm not going to work that out by the way. I guess I could. 50 times 101, so that would be 5050, I think. Yeah. Please correct me if I got that wrong. So that's how this happened, and I can show you these formulas in class. If you ever forget these formulas, which I do all the time, you can always just do it the exact same way that Gauss did it. Just get the series, rewrite it in the opposite order, add them all together. You can figure it out pretty easy instead of trying to remember these formulas. Let's do an example of something here. So, an example. So for this particular sequence 1, 7, 13, 19, etc., etc. Firstly, let's try to find the sum of the first 20 terms. And secondly, I'm just trying to squeeze it in a bit more, find n if Sn equals 225. Alright, let's have a look at this question. First part, find S20. Okay, so we know that n's equal to 20. What else do we know? The first term is 1. What's the difference? It's 6 every time it's going up by 6. Okay, now we've got two formulas, remember? And so one of the formula involves the last term and one doesn't. We don't know the last term here, okay? We just don't know. So we need to use the first form. So what was that formula? The first form, the formula that we need is that Sn equals n over 2 2a plus n minus 1d. So that's the form that we need to use here because we don't know the last term. Easy. So we want S20. So S20 is equal to 20 over 2 times by 2a plus n minus 1. I'll just do it for you because I'm nice. D6. Okay, so all we need to do is evaluate that, whatever that's equal to. So that's equal to 10 times 19 times 19 times 6. Why do I choose such horrible numbers? Well, 20 times 6 is 120 minus 6 is 114, so 116. So 1160. That didn't turn out too bad. That's the sum of the first 20 terms. Nice and easy. Beautiful. The next part, I'll go to the next page, I think. Will I remember it? I will. Okay, so part B. What did we have? I'm just trying to remember. We had A equal to 1, difference was 6, and no, we don't know n. N equals something. But we were told that Sn equals 225. Okay, so we want to find what is, we know that the sum's equal to 225. How many terms does this particular sequence have? And so all we do is plug that into a formula. Again, we don't know the last term, and so we don't use that second formula. Let's look that we want to use this formula here, n over 2, you get used to it, 2a plus n minus 1d. Okay, Sn is 225, so 225 equals, we don't know n over 2, 2a is 2 times 1, plus, we still don't know n, and the difference is 6. So all we need to do now is solve this. Now, I'll go and do this by algebra, but you will, in specialist math, why waste time? Plug this into your calculator, solve. In fact, I'm not going to waste my time either. Just go straight to your calculator and solve this. Maybe I will solve it. No, I won't. I'm not going to waste time doing this. Just solve for n. Okay, it'll be a quadratic because you get n times an n. Just solve that, and whichever n is positive is your answer. I'm not going to waste time doing that. Okay, go and do that now. I'll show you one more example here. Just a second example. Okay, find the sum of 16, 13, 10, down to negative 32. Okay, find the sum of this bunch of numbers. Okay, so let's have a look at it. Find the sum of this. You'll notice that in this question we're given the last term. Okay, so that might give you a hint. We want to be able to find that last term. Let's write down what we know. What do we know? First term, 16. The difference, it's going down, so it'll be negative 3. Do we know the number of terms? No, we actually don't know the number of terms, which is really annoying because n is like the cornerstone of what we do in sequences and series. Quite annoying, but we do know that the last term is negative 32. Okay, so in looking at our formula, we've got Sn equals, now we know our last term, so we want to use this formula. But the problem is that we don't know n. How do we find n? This is the problem, okay? So how do we find n? We go back to our original definition of the nth term. Tn is equal to a plus n minus 1d. That's our nth term. Because we know the nth term, we know the number of terms. The last term is negative 32. And remember that L is just Tn, the last term, okay? And in this case it's negative 32. So that helps us find the number of terms if the last number is negative 32. So Tn, negative 32, is equal to, what was A? 16 plus n minus 1 times d, which is negative 3. And all we need to do is solve this for n. That'll tell us how many terms there are. Okay, fantastic. So let's just solve this. I'll move the 16 over this side straight away. So that's negative 48 equals, I'll just expand this, negative 3n plus 3. Perfect. I'll move this 3 over to this side again, and so we'll minus 3 from there. So that's negative 51 equals negative 3n. Therefore, n is equal to negative 51 over negative 3, which would be 17. Is that 17? 24? Yep, 17. Okay, so therefore there's 17 terms. Okay, so we're only halfway there. I wonder if I can squeeze this in now. I probably can. I'm going to be naughty, okay? I should have just taken up less space. I'm just going to continue here, okay? Sorry about that. So we found out that there's 17 terms between here and here. You can also use your brain and look at it and probably figure it out. Decide which way is faster for you, but that's one way to find out that there's 17. If it was a massive sequence, you'd use this. If it was just a short little one where you can see, oh, there's 8 terms or something, you can just use that to find out how many terms there are. Alright, now let's use our formula up here, Sn. So S17, because we know there's 17 terms, equals n. What was n? 17, because there's 17 terms, over 2. What was A? A was 16. And what was the last term? The last term is negative 32, so minus 32 equals 17 over 2. 16 minus 32, that's just negative 16. And that'll be, I'm just going to do it on the calculator. Calculator. I should have my TI Inspire up, but I don't. So that'll just be 17 times by negative 8. And, oh, I didn't do that right. See, this is just embarrassing now. So negative 8 times by, I should have just done, yeah, you're all laughing at me, negative 136. Okay, so your answer here is negative, oh, what's it doing? Negative 136. That is the sum of the first 17 terms. And you go, why is it negative? Well, because these numbers get negative quite quickly, and if you start adding them all up, it becomes negative. And that's the end of arithmetic series.